all standard deviations are the same. They're just stretches of each other. So what I'm saying here applies to literally everything. If we're talking about trees in a forest, or IQs of people at a school, or how tall are basketball players, if they form a normal distribution, which they normally do, that's why it's called normal, then they obey this. It's symmetrical about the mean. If you are within one standard deviation of the mean, plus 1 or minus 1, if you're anywhere in that group, in other words, you're an ordinary person, that's 68%. So to make it real, let's use the most famous normal distribution of the lot, IQ. So we can say 95% of people in the world have an IQ between +2 and -2 standard deviations. In other words, 130 down to 70. 95% of people. How clever do you need to be more than 3 standard deviations above the mean? Well, that's basically 1 in 1,000 people. 1 in 1,000 people is above 3 standard deviations or below 3. So in other words, 145 down to 55 is 99.7% of people. So that's the most famous standard deviation. But the other crucial one is so famous it has its own letter called Z, and it is the simplest one. I think of it as temperatures at the ice cap. Z is 0 is the mean. It's a cold day, but sometimes it gets a bit warmer. Sometimes it's a bit cooler. The really nice thing about this distribution is that when you say you are, say, 2 degrees above the normal today, well, what you're saying is 2 standard deviations. And so if I have an IQ of 130, then it has a Z value. What is its Z value? How many standard deviations is that above the mean? It's 2. And so what is the exchange rate between IQ and Z? I can write Z equals, what is the exchange rate for any number? Let's put K. I've got an IQ of K. What would you tell me? How many standard deviations above the mean am I? Well, K minus 100 over 15. So, for example, if K is 115, then 115 minus 100 is this distance here. Divide by 15, that's what, this distance here. Divide by 15, that's 1 standard deviation. Similarly, if I have an IQ of, let's go for 70, well, 70 take away 100 is negative 30. Divided by 15, negative 2. Means you're 2 standard deviations below the mean. Now, we're a selective school. And, well, I don't know what our mean is. I would hope it's above 100. I don't know what our standard deviation is. I'll bet it's less than 15. 15 is the standard deviation of the population. But of a school, we're quite narrow. So I'd imagine sigma is smaller. But I don't know. Now, if I've got an IQ of 70 in this school, what is the exchange rate? I've got an IQ of 70. I'm going to subtract the mean and divide by the standard deviation to get into the Z world. And that's telling me, remember that Z answers the question, how many standard deviations above the mean are you? How many standard deviations? Well, 70 minus the mean, divide by sigma. That's the formula. You've got to learn that formula. So let's have a look at this quite hard question. I've got an unknown normal distribution. I don't know the mean or the standard deviation. I've got a nice diagram. And what I realize is that I have to convert this into the Z world. The reason is that on my calculator, I can operate in the Z world. Here is the Z world. It has a mean of 0 and a standard deviation of 1. And I'm not going to type anything in X because I'm going to go to here and type 30%. It's got a really nice diagram. 5244. So in the Z world, that Z value there is 0.5244. Now, how do I convert from my X world of trees to the Z world? That number 16 there, I subtract the mean and I divide by the standard deviation, both unknown. That's equal to 0.5244. Similarly, this one here, I can say 12 minus the mean divided by the standard deviation is equal to, and then go to the Z world on my calculator, and I can change it to tail left. Again, I won't type anything in there, and then do it in here, 0.2. So that's negative 0.841. Negative 0.841. And so that is now simultaneous equations. And the nice way of doing it is to, I would say, write 12 is equal to mu minus 0.841 sigma. I'm a bit below the mean. And 16 is mu plus 0.5244 sigma. And you can see by symmetry, this is really quite nice. And also that fits with the calculator's functions. So even though it's easy simultaneous equations, I would still use the calculator. Really make sure you've done it right. Look at the way the calculator's set up. X plus y equals constant. So I very carefully set it up correctly. And then I can just solve it. So the mean is 14.4 and the standard deviation is 2.89. Really nice.